we're going to do a little, today we're going to talk about multiplying monomials, but before we do that, last time we ran out of time a little bit, so I want you to do a little warm-up. You could do this actually continuation from last night's note. Can you guys all do this one? It'd be like your homework kind of question.
Yeah.
Parentheses 3a cubed minus 2ab squared, close parentheses, minus a cubed minus 4ab minus b cubed in parentheses. Go ahead, I'll wait. Make sure you change everything to addition first, okay? Go ahead, everybody try. And of course, you should all know how to do this because it's very similar to your homework. And you may ask your group if you're stuck. Okay, that's fine too. Who could tell me how to change everything into addition? How many, by the way, how many subtractions do we have here in this problem? Show me with your finger. How many subtractions do you see? Yeah, 100% participation. How many subtractions do I have in this expression? One, Kevin? Good. Okay, there should be 4. 4. Right, here's one right here inside the parentheses. There's 2 of them inside the parentheses, and then there's one outside the parentheses right here, subtracting the whole thing. Right? You guys remember? Yeah, so you're going to change everything to addition now. Who knows how to rewrite this into addition? Carolyn, go ahead. Shh, listen.
3a cubed
Yeah.
plus negative 2ab squared
Right?
plus negative a cubed plus 4ab plus b cubed.
Okay, you skip a step, but you're right. You're right. Because I did this. I changed this to plus negative 1 times the whole thing. And then, of course, when you distribute this, how many times do I need to multiply this negative 1 by?
3.
3 times. Because how many terms are there inside the parentheses? 3. And isn't there a really invisible 1? When you distribute 1 to this, what happens to the parentheses? Goes away. So this is what you told me. You're right. Okay. Now, how many like terms do I have in this expression? Michael? What are they, Michael?
3a cubed and negative a cubed.
Yeah. Are there any other like term?
No.
No. And since everything's in addition, could we use the commutative property of addition and gather the like terms now? Yeah. So I'm going to rearrange it this way. Right? These are the only 2 like terms, right? None of the other terms are like. How many people got? So of course, this is negative a cubed, right? What's the coefficient of negative a cubed? Negative 1. Is that invisible 1 again, right? So isn't this, how many people got 2a cubed minus 2ab squared plus 4ab plus b cubed? Raise your hand. Okay, if you didn't, some of you didn't touch what? Oh, you got it? If you didn't, go ahead and fix it now. Okay, most of you got it right. Okay, I'll give you time. Take a look at it. Look at your mistake if you didn't get that, okay? Now we're ready for the new lesson, multiplying monomials. Turns out we're going to have to use that, you know that example we just did? We have to remember that too because we're going to be combining that with multiplying monomials. Anyway, so go ahead and write this down. This is our topic, multiplying monomials. So first I want to start with this simple example. X cubed times x to the second power. Okay. Anybody know what the answer for this is if I were to multiply x cubed times x to the second power? All right, Jason, what do you think, sir?
I don't know if you can do this, but I'm going to guess.
Okay.
It's
X to the 5th. How many people agree with Jason?
Yeah.
Anybody have different answer?
Look at that.
Did anybody come up with x to the 6th power?
Oh.
Just like do 3 times 2? No?
Whoa. Wait, oops.
That's
Oh.
Do we add the exponents or multiply? It says multiplication, but are we multiplying them?
Yeah, but
Right, exactly. Even though we're multiplying, so let's think about this. What does x to the 3rd power mean? Yeah, how many x's are you multiplying? What about x to the 2nd? So how many x's are you multiplying all together? So do you add the exponents or multiply? Do you do 3 times 2 or 3 plus 2?
3 plus
You do 3 plus 2 because this exponent tells you how many bases you're multiplying, right? So you have to add, okay? Some people think, oh, there's a multiplication symbol, so they think that they should multiply the exponent. That'll be wrong, okay? So you add the exponents. Does that make sense? Okay? You see that? All right, what about this? Who could tell me what we get for x cubed times y to the 2nd? Go ahead, I'll give you time. Think about it. I'll give you time for you to think about what we get for x to the third times y to the second. Go ahead, everybody think about it. Okay, Royce, what'd you get?
X cubed y squared.
X cubed y squared. You got the same thing?
No.
Oh, okay. Did anybody get something else? Chuck?
Is it x y to the fifth?
X what?
X y to the fifth.
X y to the fifth. Could we add the exponents here?
No.
Now, the answer is no. You can. Why not, Chuck?
Oh, because they're not the same coefficient.
Yeah, not coefficient. Yeah, they do not have the same base. Only time this works is if you have the same base, right? Here it just means you multiply x 3 times and y twice. Correct? So you can't really do much. That's it. That's the expression. You can't. That's it. You can't do anything.
Oh, it's already simple.
Yeah, it's already simplified. You can't really do much. Yeah, so please be careful. You have to have same what again? Base to be able to add the exponents. Okay. What about then this one here? Everybody try. Oops.
So you do x3 y to the second.
Yeah, you just leave it as x3 y to the second. That's all you could do. Okay. All right. Hold on. Okay, everybody try this one then. What about if I have 5 to the third times 5 to the eighth? So this time my base is not a variable, it's a number. So what would you get if I have 5 to the third times 5 to the eighth? Okay, Angel? 5 to the 11th power. How many people got 5 to the 11th power? How many people have different answer? Yes, sir. What'd you get?
25 to 11.
25 to the 11. How many people got 25 to the 11th power? Okay, raise your hand. Very good, very good. That's how you get it wrong. Because can somebody see why you get, that'll be wrong if you write 25 to the 11th power. Chuck.
Because like you have like the same base if you want to add it, right?
Exactly. Look at what we have here. When you're adding the exponents, isn't that how you're really multiplying the bases? You get 5 to the 11th because how many 5s do you have? 5 to the third says how many 5s?
3.
How many 5s do you have for the 5 to the 8th? 8 of them. And how many 5s do you have altogether?
11.
Do you have 25 11s?
No.
I mean, do you have 11 of 25 multiplying? Or do you have 11 of 5 multiplying? 5. The base doesn't change. Please do not multiply the base. Does that make sense? When you're adding the exponents, that's when you're really multiplying the base. Please do not do that on the test. I cannot tell you how many times people multiply the base. That will be wrong. If you have the same base stays the same, and as you're adding the exponents, that's really when you're multiplying them. Jason.
So you should never multiply two bases together.
Well, if you're going to add the exponents,
But what
I
if
mean-
you're not adding?
then that's fine. If you have 5 times 5, you know that's 25.
Oh.
You know what I mean? But isn't that same as 5 to the second power?
Yeah.
You know what I'm talking about? So if you're going to add the exponents, you do not multiply the base. But if you're just going to multiply two numbers together, then of course you multiply them. You know what I'm talking about? You guys? Yes. Question.
On our homework, we have to simplify. Like if this is a question on homework, we have to simplify 5 to the
Good question. So if you have 5 to the 11th power, that's really a big number. You don't have to. But if it's like 5 to the second or third, you should know what that is. So you should write that out. Good question. Okay. So if it's some number to a really high power, you don't need to multiply it out. Okay. So let's think about this. This is a fact. What do you think then if I have a to the n power times a to the nth power? What do you think this would become? Always? This is a shortcut, by the way. One person see it? If you have the same base with exponents like this, Sam? A to the mn? No. So you don't multiply m and n. What do you do with m and n, guys?
Oh,
Yes, sir.
a to n plus.
Thank you. It's a plus m. You have to add. Okay. So this is a fact. You add the exponents, just like how we did it here, right? When we had x to the third times x to the second, did we add 3 and 2 together? So this is a fact. If you have the same base, right, you add the exponents. Okay. Any question? But you have to remember that you have to have a what? When does this only work? When you have the same
base.
same base. So please write that out. Write that down. Must have same base. Otherwise, this would not work, right? We just saw that one. X to the third times x to the second one. Yes, question?
So that's the final answer. Oh,
For what?
the back question.
There's no numbers.
Right. If I have a to the m times a to the n, you could always follow this pattern, right? It's going to be a to the m plus n. Do you get that? That's a fact, okay? So that's a general, right, way of saying if you have the same base, all you have to do is add the exponents. Let's do some examples then. Any questions?
No.
Okay. So knowing that fact above, look at example 1. Instead of a, I have y. Okay, and then I have y to the fourth times y to the second. And m is 4 now, n is 2. So, can somebody, question?
I just go to the bathroom.
Go ahead, take your pass. So what do we get then? What's the answer, Dana? Y to the 6. How did you get y to the 6? You add the exponents, exactly right. Because we have the same base. Does that make sense, guys? So, what kind of work do you think I want to see on your homework? Yes, sir. Yeah, y and then 4 plus 2 like this. And then I want you to write y to the 6 like that. Is that okay? All right, so that's the work I want to see.
So we don't have to write like y times.
No, you don't want to write y 4 times. Because what if I have y to the 100th power? Are you going to write y 100 times? Okay, so I want you to use this shortcut. Okay, this is a shortcut, isn't that right? But whenever you get confused, guess what? Could you write it out?
Yeah.
Yeah. Like Mr. O says, when in doubt, write it out. Have you guys heard it? Okay, when in doubt, write it out. Okay, so if you ever get confused, guys, with these, and I'm telling you, even though this is very simple, sometimes when we combine this with some other sort of question, people sort of get confused. Okay, so I want, whenever you're in doubt, just write it out. Okay, but since we know we're talking about this rule, you could just add the exponents. Okay. All right, then what about example 2? Let me give you something a little bit different. This time I have some coefficients. Okay. Example 1 had coefficient of 1 only. This time we have other coefficients. Go ahead, think about this. Everybody try. See what we get here. Oh, wait. Notice on example 2, look at what kind of operations do you see in example 2? All the operations are multiplication. And what sort of property does multiplication have that we like?
Commutative.
Raise your hand. Yes. Commutative property of multiplication. In other words, we could rearrange them. How many people notice that? Oh, that's simply, I could just rewrite them like this. I could separate them and write 4 times 5 times n to the third, n to the second. Do you see that?
Yeah.
Okay, of course. Then what do we get when we do this? Lindsay, what'd you get?
I got
20 n to the fifth. Did you show this work where you add the exponents like this? Okay. How many people got 20 n to the fifth? Raise your hand. Is this pretty straightforward? Okay, so when you're multiplying all these monomials together, you could just gather all the numbers and gather all the variables together and then get the answer this way. Yes, sir?
Do we have to show where we're using commutative?
It'd be nice, but yeah, I want you to show this work, the one in highlight. You don't have to show the work where you separate them, but I want you to, group them together this way and move them, change the order. All right, let's look at example 3. May I move on? Again, example 3 is very similar to the one we just did, except now instead of just having one variable like x, we have x and y. Okay, so go ahead and simplify this expression. We're multiplying a monomial times monomial. Again, all the operation between all the numbers and variables are multiplication, so you could change the order because of commutative property and simplify that way. Okay, go ahead. I'll wait. Okay. Okay, good. So first of all, how many people change so that you gather all the numbers, all the variables with x's and all the y's? Okay, good. How about, I want to ask, okay, Christina, what'd you get then afterwards? So we multiply negative 4 times 7, which is? Negative 28, okay, and then what about x? By the way, did anybody put down x to the first like this, how I did it here? Okay. Why do you think I do that, by the way? Because even though it's invisible 1. Yeah, if you don't write 1, guess what people think? X to the second times x to the first, they think, because they don't see anything, they think it's 2 plus 0, right? Is that right? No, so Christina, what should we write? X to the what power? This is x to the third, because remember there's that invisible 1 there. You think it's a good idea to put down that invisible 1? Write it out? Okay. What about this? X to the fifth? Y to the fifth times y to the fourth, what do you get? Y to the 9. How many people got the answer here? Negative 28, x to the third, y to the 9th, raise your hand. Very good. So guys, please, remember to use that invisible 1 for that exponents, especially if you're going to add these exponents, right? Like I said, if people don't see the exponent, they think it's 0. Is it 0? No, there's that invisible 1 there, right? So please be careful. How many people got this right again? I didn't see the. How many people got this right? Negative 28. Very good, most of you. Okay. May I move on to example 4? Is this pretty straightforward? Okay, good. All right. Yeah, this is pretty straightforward. Now look at example 4. Only thing that's different than example 4 from other one is what? What's the difference? Yeah, you now have, what do we call these numbers in front of these variables? Yeah, but what do we call these numbers in front of these variables that's multiplying? Coefficients. Now the coefficients are fractions. That's the only difference. That's the only difference. But is this any harder than the other ones? No, it's not. You know how to multiply fractions, don't you? Okay, go ahead, everybody try. Go ahead, everybody try. How many people gather the fractions together and then the x's together and the y's together? Okay, good. So did you all do this? How many people canceled out 16 and 4 and then 5 and 15? Good. Carly, what'd you get?
My answer?
Yeah.
I got 12
Yeah, let's listen. I can't hear. Here you go. Go ahead.
I got 12 x to the 5th power, y to the 3rd power.
How many people got 12 x to the 5th and y to the 3rd? Very good. How many people wrote that invisible one there?
Me.
Okay, because if you don't, I'm telling you guys, sometimes people do this sort of fast and they don't see the invisible one in exponents. They just think that it's y to the 2nd, right? Y to the 1st times y to the 2nd is y to the 3rd. Yeah, question?
Yeah, I didn't know that you could do the cross.
Yeah, you could. Because when you're multiplying two fractions together, right, you could divide top and bottom by the same number. Can't you? Right?
Oh, okay.
Doesn't 5 go into 15 3 times?
Yeah.
Yeah, and then doesn't 4 go into 16 4 times? Now, Jason, if you don't, I could actually do it this way. You could think of it this way. Look, you have 16 over 5, right? Times 15 over 4. Now, everything's multiplication, isn't it? Because how do you multiply fractions? You multiply them up, right across, straight across, right? All the numerators together, denominators together. Now I'm going to use commutative property of multiplication and write 4 over 5 like this. And look, you could simplify these fractions. You could think about it that way too. Then 4 goes into 16 4 times. 5 goes into 15 3 times. That's how you get 4 times 3. Okay? So still, you see how commutative property still works here? Yeah. Okay, may I go on to example 5?
Yes.
Okay? Here we go. Look at example 5. Example 5 looks a little bit different. Why? Anybody see the difference in example 5 compared to all the other ones? Raise your hand. Raise your hand. What do you see? Dana? There's addition in the middle. What kind of skill do you think you need for this one?
Addition skills.
Which means, right, what sort of addition skill? Adding polynomials, which is what we talked about
Yesterday.
Very good. Go ahead, everybody try. So this is combining the things that we learned last time with the multiplying monomials, okay? Go ahead, everybody try. See what you do here. Now, let me ask you this. Can I move this a square, guys, all the way to the left?
What? No.
In other words, can I gather all the a's like this? A to the 4th? No, why not? Raise your hand. Why can't I get all the 4 a's into one, like, Carolyn?
Because there's an addition.
Yeah, right. Because there's an addition sign. So what are we going to do?
It's a binomial.
Yeah, so we have to multiply the 2 monomials together and add it to 2 monomials together. How many people gather all the a's and all the b's and all the numbers? They'll be wrong, right? Do you see why it's wrong? Guys, listen. Because there's addition symbol in the middle, hello, you still have to follow the order of operation. You have to multiply these 2 monomials together and then these 2 monomials together, then you could add. Does that make sense? Okay, please don't get all the a's, okay, that'd be wrong because there's addition symbol here.
If you're all adding it together.
Then you could add all the like terms together, but they have to be like terms, okay, not actually a factor. Remember like terms, guys?
Yeah.
As you go over this, it will make sense. Watch this now. May I have your attention? Okay, so first, Claire, what do I do? I'm going to multiply the 2 monomials together. Tell me what to write.
Negative 12 a to the 5th and b to the 4th.
Very good. And what about the 2 monomials on the right? How about Brandon? What do I get here? Yeah. B to the 4th is correct. So I actually, separated them and then gather all these together. Now, am I done? No. Look, now you could add them together because these 2 are like terms, right? Kevin, what do I get when I add them together?
A negative 10 times 2a to the 5th times 2a to the 4th.
Correct. Because I'm using the distributive property backward. Again, you don't have to write this step, but in the back of your mind, you should have this. And how many people got negative 10, a to the 5th, b to the 4th?
Yeah, I got 3 answers.
Okay, if you did not, fix it now. Go ahead, talk to your group. Go ahead, fix it if you didn't get this. This is important that you get this. Go ahead, everybody try. Go ahead and fix it if you didn't get this, guys. This is the answer. Do you see a mistake? Some of you are having trouble understanding. Let me ask you this. Forget about this thing. Let me just ask you this, okay? If I have negative 12x plus negative 12x squared plus 2x squared, what do you get as your answer? Oh, I'm sorry. What do you get as your answer? If I have negative 12x, forget about all these things. Think about what we did last time. Are these two like terms?
Yeah.
Do they look exactly like except for their coefficients?
Yeah.
So what is negative 12x squared plus 2x squared? Is it negative 10 only? No, it's negative what? Negative 10x squared. Is it negative 10x to the fourth? No. Some of you are thinking that you just get negative 10x squared, right? So that's why, look, when you're adding these like terms, do you get negative 10a to the 10th, b to the 8th? Do you add the exponents here, guys? No. Do you see why I told you that it's a good idea to use the distributive property backwards here? If you did that, you will see, Carolyn, that you don't get a to the 10th, b to the 8th. Do you see why I'm telling you to do these, even though it's extra step? Because if you do it this way, you won't get it wrong. If you just blindly follow the things that we've been doing, you would just go, oh, don't we just add the exponents? No, that's only when you are. When do you add the exponent? When you're multiplying. Are we multiplying or adding?
Adding.
Do you see why this step, the distributive property backwards, really will help you? Right? Do you see how you could get it wrong if you wrote negative 10a to the 10th, b to the 8th? Any questions? Jason, does that make sense now? Okay. May I move on? Yes, sir. Say it again. What?
I got it wrong too. I'm not gonna add the b. I got it wrong. Because you have b.
Yeah, isn't it 2b?
Yeah.
Plus b to the 4th plus b to the 4th?
What do you see? B to the 4th times b to the 4th.
On this side, there's one b, there's multiplication on this side.
Yeah, but it's addition.
That's multiplication.
But even if you distribute it,
Do we distribute this 2 to a to the 5th, b to the 4th?
No.
When do you distribute?
This parentheses.
what do we do with these?
There's one b one on one side, one b one on the other. If we want to add.
What do you want to add? Let me, guys, I can't hear the. Okay, say it again. What's your question? Which line are you looking at? First, second, third, fourth, or fifth? Third line. Okay, here's the third line. What do you want to do?
You know how there's a b?
There are two b. There's b to the 4th over here, and there's b to the 4th over here. Yes.
Yeah, I just want to add it.
And what do you think you should get? 2b. Okay. Instead of x squared, I have this whole thing. Jason, do you add when you add negative 12x to the second plus 2x to the second, right? Do you get negative 10 2x to the second? Samuel, do you get you want to do here? How come we just got x to the second here then? Why didn't you get 2x to the second? If you think that there's x to the second, x to the second. This is a whole monomial, Samuel. This monomial, the coefficient is negative 12. Do you see I'm using the distributive property backwards? So I am just subtracting negative 12 times 2. I mean negative 12 plus 2. That's the only thing that you're doing. This a to the 5th, b to the 4th is the like term there by itself. Right? I could actually add more. No, they're not, because it's all multiplication. If you see this, hold on guys, don't pack up. If you see this part right here, this should convince you that you just need negative 10 a to the 5th, b to the 4th. You don't need to add the b's. If you don't believe me, multiply it back. Hello? Does that make sense? Are you sure? Okay, that's important, guys, that you get this. Class, do you understand when to add the exponents?
Yes.
Any question?
No.
All right.